Good morning, student. I trust you are having a great time this morning. I'm so happy to have you back on today's class. I thank God for giving us life and making it possible for us to be alive in the land of living. God has been giving us life and God has been protecting us. To Him alone be all the glory. This morning, there is a topic before us that we're going to discuss. We're going to look at number system. Number system. Now, what is a number system? Now, every computer system, every digital computer system and electronic system makes use of binary system, which is zeros and one. That zeros and one is what the computer understands. Assuming you want to type something or you want to type a name, the computer don't understand that particular thing you are typing. What the computer is understanding is the zeros and one, which can be translated or converted by the help of the translator, compiler, and interpreter. So in this number system today, we'll be looking at the concept of number system and how to convert from one base to another. Okay, now let me throw more light and explain. We say computer and other digital system process information as their primary function. Therefore, it is necessary to have method and system for representing information in form that they can be manipulated and stored using electronic or other hardware. So other hardware and other electronic uses this number system. For example, let me give the example, the one you have in your house, like your switch you have in your house, which you trigger off and on. That's when you trigger it off, it is called 0. When you trigger it is called 1. That means it has a high signal called 1 and a 0 signal and a low signal which is called 0. So this number system in computer system, that is what computer is using to translate and to understand what the user or the command given to it by the user. Okay, now binary system is very important in computer system. It's very important in computer system. So we're going to look at how to convert from decimal to binary, and from binary to octal, and from octal to hexadecimal. Now we have types of binary type of number system. We have the types of number system. The first one we have is the one we call decimal. Decimal ranges from 0 to infinity. That means you count from 0, 1, 2, 3, 4, 5, 6, 7, 8. That's how decimal ranges from 0 to what? Infinity. Now this decimal consists of whole numbers, which include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this decimal system, everybody is making use of this decimal system. Even though you go to the bank to pay money, you pay it in decimal system. Either you are paying 1,000 naira, or you're paying 2,000 naira, or you are paying in 1 naira. That is decimal system. Now the binary system, which the computer converts. Now after you have written it, the computer converts it. It's always in what? Zeros and one. So this table now is giving us the equivalent of binary system to decimal, and from decimal to octal, and from octal to hexadecimal. So the type of binary system we have in computer is we have the decimal, we have the binary, we have the octal, and we have the hexadecimal. Now let me explain more. This table you are seeing here is explaining to us how to convert from, or the equivalent of what you are going to get when you convert from decimal to binary, and from binary to octal, and to hexadecimal. Meaning that when you convert 0 to binary, you are going to get 0. When you convert from 0 to octal, you are still going to get 0. When you convert 0 from octal to hexadecimal, you are going to get 0. So this table is just showing us what? The equivalent. Now when you look at the hexadecimal, you look at that was a change when we have something like 10. The equivalent of 10 in hexadecimal is not a number but it's called A. The equivalent of 11 in hexadecimal is called what? B. That is how it's constant. So this table for hexadecimal is constant. It's expected that you should study the table. It's expected that you should study the table. When you still come back to school, we are going to look at this table and solve and show you how to prove that 10 in decimal is equal to A. Okay, that's a short clip I want you to watch now. We're going to use this short clip and be solving, and we're going to be proving how all these things is possible in our next video. So I'm going to start from the one that is very simple. So we are going to learn how to convert from one base to another, especially how to convert from decimal, which we can say call denary, to base 2, which is binary. So when they say base 10, it means they are talking about decimal. When they say base 2, it means they are talking about binary. When they say base 8, it means that they're talking about alter. When they are saying something like base hexadecimal, it means they are talking about base 16. Okay, let's watch this clip now and see how to do the first one. Definition of number system and types of number system. With this short clip, I'll be showing you how to convert from one base to another base. Assuming you are asked to convert from base 10 to other basics, how are you going to do that? Like you converting from base 10 to base 2, or you converting from base 8 to base 2, or moving from base 12 to another base like base 2. So we are going to show you how to calculate it, but we are going to start conversion from base 10 to other bases. Let's start from example. We have convert 25 base 10 to base 2. How are you going to do that? Now, for you to convert 25 to base 2, you are going to divide it by what? 2. This 25 is in base 10. So for you to move it to base 2, you will divide by what? 2. Assuming here is now 3. What you are going to do is to divide it by what? 3. But we are trying to convert it to what? Base 2, which is what? Binary system. For example, let's solve this now. Solution. Let's solve this. So look at how you're going to solve it. You are going to have 25 divided by what? 2. Now I'll have R as my what? Remainder. Now 25 divided by 2. 2 divided by 25. We're going to have 12 here. Remainder 1. Why are we having 12 here? Because when we multiply 2 by 12, we're going to get 24. And if I add it 1, it's going to give us what? 25. So 2 divided by 12, I'm going to have 6 remainder 0. 2 divided by 6, I'll have 3 remainder 0, because 2 is divisible by what? 6. You can divide 2 by 6 and you get 3. Now we have 2 divided by 3, we're going to have 1 remainder what? 1. Now 2 divided by 1, 2 cannot divide 1. We're going to be having 0 remainder what? 1. Now we are done, because you cannot still divide down. We are having 0 remainder 1. So how are we going to bring out our answer now? We are going to move from the descending to what? Ascending. Or we can say move from the bottom to what? The top. So we are going to say, for us to get this, the final answer, 25 base 10 will give us, trying to give us 1, 1, 0, 0, 1 base 2. Now, what are we trying to say is that when we convert 25 base 10 to 2, this is what we are going to have. If we convert base 25 to 2, is what we're going to have, because base 25 is in what? Base 10. Okay, for further clarification, let me go back to this and explain more. Like I said, don't forget, when you divide 2 by 25, you're going to get 12. Divide 2 again by 12, you are going to, when you divide 2 by 25, you are going to get 12 remainder 1. Now, when you divide 2 by 12, you are going to get 6 remainder 0. When you divide 2 by 3, you are going to get 2 by 6 will give us 3 remainder 0. And when you divide 2 by 3, you are going to get 1 remainder 1. And 2 divided by 1, you are going to have 0 remainder 1. Okay, let's just solve this example to clarify more. Now, so assuming we are asked to convert
45 to base 2. How are you going to do that? The same. Remember, you're going to divide it by 2 because it's in base what? 2. So we are going to have the same thing. 45 here will be giving us base 2. We are going to have 45. Still, don't forget to put your remainder. Very important. Now, 45 divided by 2, we're going to have 2 here. We're going to have 22 remainder 1. Now, 2 divided by 22 is going to give us 11 remainder 0. We're going to have 0 here. Now, when we say 2 divided by 11, when we divide 2 by 11, we're going to get 5 remainder 1. 2 divided by 5, we're going to get 2 remainder 1. 2 divided by 2 is going to give us, when we divide by 2, we're going to have 1 remainder 0. Now, if we say 2 divided by 1, 2 cannot divide 1, we'll have 0 remainder 1. Don't forget, I say we move from the descending towards ascending. So, 45 base 10 is going to give us 45 now. 45 base 10 is going to give us, we're going to move from here now. 1, 0, 1, 1, 0, 1, base 2. I believe that you have understand what I've said, and God bless you. Thanks.